Hi students, welcome to Math4U. Today in this session we are going to discuss about Herons Formula. This is from grade 9 chapter 12. So before going deep into the chapter, let's see what is an area. Area can be defined as a space occupied by a flat shape or a surface of an object. So the area of a figure is the number of unit squares that cover the surface of a closed figure. So it can be measured or it can be represented as in square centimeters, square meters, square feet, square inches, etc. Okay. So let's see some of the figures and how can we find out the area of those. You have already learned in previous classes, okay, how to find out the area of figures. So let me give you some figures over here. Circle, square, then rectangle, then parallelogram, and one more figure let me give you, that is trapezium. Okay, here comes the trapezium. Yeah, so let's see how can we find out the area of these figures. So if the r is the radius of the circle, we can find out the area of this circle by using the formula pi r square, right? If A is the side of this square, you can find out the area by using the formula A into A, that is A square. For the rectangle, I'm taking the length as L and breadth as B. How can we find out the area? Yes, that is L into B. And when it comes to the parallelogram, how can we find out the area of a parallelogram? If the base is B and I'm marking the height of this as H. Yes, we can find out by using the formula B into H. And in the case of trapezium, if we have the parallel sides, the measurements as A and B, and I'm going to mark here the height as H. How can we find out the area of a trapezium? The area of a trapezium we can find out by using the formula. Yes, very good. Half into A plus B multiplied with H, right? So let's see how can we find out the area of some kind of triangles. So first I am considering here a triangle that is a right angled at C. That is A, B, C. Here it is right angled. And let this be the base, and this is the height, right? And the base of this is 5 centimeter, height be 12 centimeter. How can you find out the area of a right angled triangle? So here area of triangle ABC you can find out by using the formula half into S base into height, right? Yes. So and now we are going to substitute half into 5 into 12. So you can cancel these two and you will get the answer as 30 centimeter square, right? Now let's see how can we find out the area of an equilateral triangle. Equilateral triangle. Okay, so I'm going to draw an equilateral triangle over here. Let this equilateral triangle be X, Y, Z, and let this each side is a 10 centimeter, or we can take it as in meter, 10 meters each. Okay, equilateral triangle means all the sides are equal. So how can you find out the area of an equilateral triangle? So here area of triangle X, Y, Z we can find out by using the formula root 3 by 4 A square, where here A is the side of the triangle. Now in this case we can find out root 3 by 4 into A we have as 10. That is equal to root 3 by 4 into 100. You can cancel these two with 25 and you will get the answer as this is equal to 25 root 3 meter square, right? And now we are going ahead with the next. That is, we are going to find out the area of an isosceles triangle. Okay, isosceles triangle. Yeah. So let me draw an isosceles triangle over here. Isosceles triangle means, you know, two sides are equal and the third side will not be equal. I think this looks like an equilateral triangle. I will draw it again. Yeah. So let the two sides of this triangle be same, and I'm going to take here this side as 5 centimeter. This, suppose this is also 5 centimeter, and I'm taking this part as 8 centimeter. Okay, so I'm going to mark this as PQR. How can we find out the area of the isosceles triangle? For this, I'm going to construct a perpendicular from here P to QR that meets as at S. Okay, so this is the height of this triangle now. So I'm going to consider here this triangle. Okay, so consider triangle PQS, and this is a right angled at S, right? So I'm going to apply here Pythagoras theorem. You have learned about Pythagoras theorem, right? So Pythagoras theorem states that yes, hypotenuse square is equal to base square plus altitude square, right? So here the hypotenuse is PQ, so PQ square is equal to QS square plus PS square, and we need the measurement of PS, right? So PS square is equal to PQ square minus QS square. And now I'm going to substitute here. What is PQ? Yes, PQ is equal to 5 square minus QS. So the total you can see here as 8. Therefore, what about QS? Yes, of course, that is 4 centimeter. So this is a 4 square. That is 25 minus 16. You will get the answer as 9. So this 9 is actually PS square, right? So what is PS? PS is equal to root 9. That is equal to 3 centimeter. Now we got the height of this. Why? What is the need of this height here? So if we have the height, we can use the formula half base into height, right? Therefore, now we are going to find out the area of this triangle. Therefore, area of triangle PQR, we can use the formula half into base into height because we know the height now, right? So this is equal to half into base, you know, this is, now we are considering the whole triangle PQR and the base is 8, right? Into height is 3. So this 2 you can cancel and you will get the area as a 12 centimeter square. Is it clear? Yeah. So now I'm going to explain to you how can we find out the area of a triangle with the help of a perimeter. So just see this triangle. Let this triangle be again PQR, and I'm going to mark the side as ABC. How can we find out the perimeter of this triangle? Perimeter, you know, adding all the three sides together, right? So A plus B plus C. Then what about a semi-perimeter? What about semi-perimeter? Yes, semi-perimeter means A plus B plus C divided by 2. That means perimeter by 2, right? I will write over here that, yeah, that is equal to P by 2, that is A plus B plus C by 2. So don't get confused, as we can find out by using the formula A plus B plus C by 2 if A, B and C are the sides of those triangles. So here comes the Herons formula. Okay, Herons formula to find the area of a triangle. So how can we find the area of a triangle using this? Let's see. So the area of a triangle can be find out with the help of this Herons formula by using this S into S minus A, S minus B, S minus C. So there is a root, don't forget about it. So now we know how to find out S. We have the sides A, B, C also, right? So let's do an example over here using this Herons formula. Okay, so we have a triangle over here. You can see a triangle, and Let the triangle having the sides 40 centimeter, let here that is for 24 centimeter and 32 centimeter. So how can you find out S? S is equal to 40 plus 32 plus 24 by 2. Why? Because you know S is equal to A plus B plus C by 2. That is the semi-perimeter. And when you do this, you will get it as 48 meters, right? And what is the area now? Area is equal to, you know the formula, you have the formula over here, so you have to substitute for that. 48 into 48 minus A is 40, then S minus B is 24, then again S minus C is 32 over here, right? So let us simplify this. Now this is equal to root of, again, 48 into, what is 48 minus 40? Yes, that is 8. 48 minus 24 is 24 again, and 48 minus 32 is 16. So this much is the area. So now you have to calculate for this. Split this into smaller factors. Split this into factors and take the root of it. You will get it as 384 meter square. Okay, so this is how you can find out the area of a triangle using Heron's formula. I hope it is clear for you. We will see more problems in the coming videos. Thank you.